Bismillahirrahmanirrahim. Let's continue then with solving equations. 3x plus 5 equals 7. So I had enumerated to you some basic principles last time. The idea of solving an equation was first to isolate the variable like this and take everything else that's attached to the variable on the other side. That's the process of solving an equation. Solving an equation means to find the value of the variable that will make this a true statement. So the first thing was to isolate the variable. And the second thing I suggested is that you start from farthest away from the variable and move in closer to the variable until the variable is all by itself. And the third thing I suggested was performing the opposite operation. For example, here the 5 is attached to the x with the addition, so I'm going to subtract 5 to both sides, and as long as I do the same thing to both sides of the equation, I maintain the equality, so I'm good. So you do the opposite operation. Now, and then always you look for opportunities to combine like terms. Okay, so those are the basic principles of solving equations. So let's go about it. I'm going to start slow and basic, and then more advanced equations, inshallah. So here's a simple equation: 2x equals 16. Now here we have to solve for x. In other words, we have to get x all by itself, something like this, right? What's stopping us from getting there is basically just one thing, and that is 2. We have to get rid of that 2. Now the way we get rid of that 2 is we do the opposite operation. It's 2 times x, right? There's a little invisible multiplication sign. It's 2 times x. So since it's multiplied there, we divide both sides by 2. Okay, so divide this side by 2, and you divide this side by 2. Okay, then that's easy enough. 2 divided by 2 is 1x, okay, equals 16 divided by 2 is 8. Now 1x is the same thing as x. X equals to 8. Okay, so in other words, if you substitute 8 over here, 2 times 8 is 16. That will make this a true statement. That was easy enough. I'll give you another one. Minus 3x equals, okay, 12. Now here what's attached to the x is negative 3. So you have to divide both sides by not 3, but negative 3. Whatever's attached to the x, negative 3, like this. Okay, well, that's easy enough. Negative 3 divided by negative 3 is just 1. Okay, and 12 divided by negative 3 is negative 4. Right, so x is equal to negative 4. So that's that. Now here's another example. 2/3 x equals 9. Now here what's attached to the x is a fraction. Don't worry, don't panic, it'll be okay. So 2/3 x equals 9. So we have to get rid of the fraction. Okay, you can say, okay, well, divide both sides by 2/3. Okay, like this. That's okay, you can do that too. So if you divide both sides by 2/3, well, 2/3 divided by 2/3 is 1, that's x. Here we get 9 divided by 2/3, like this. And the way we do that, if you recall, you change the division into multiplication, like this, and you flip the fraction. You get 3 over 2, right? And then you get 3 times 9 is 27 over 2, like this. Okay, and that's the answer. Okay, 27 over 2. You don't have to do decimals and whatnot for us for now. But there's another way of solving this. When you have fractions like this, okay, what you do is, when you want to get rid of this fraction, you multiply both sides of the equation by what's called the reciprocal. Reciprocal, reciprocal, I'm going to do a doctorate thing here. Reciprocal, okay, which means to flip, like pancake flip. It's like you do a pancake flip on the fraction. If it's 2/3, the reciprocal of 2/3 is 3 over 2. And you multiply both sides by the reciprocal of that fraction. Okay, because when you do that, when you multiply reciprocal by the fraction, 3 divided by 3 is 1. Okay, Okay, 2 goes into 2 one time. So you have 1 times 1 is 1, 1 times 1 is 1, so you get 1x. And on this side you get, okay, you have 9 times 3 over 2, okay? Just like 9 over 1, you get multiply the tops like this, right? So 3 times 9 is 27 over 2, and that's the answer. X is 27 divided by 2. So when you have a fraction, you multiply by the reciprocal. How about this? Negative 1 thirds x equals 5/12. Okay? We do the same thing. It's negative 1/3 times x, so we multiply both sides by reciprocal of this, or just by negative 3. Okay? It's by negative 3, or negative 3 over 1, you can say. Okay? So then you have negative 3 divided this, so this becomes just x. And here you have, see, you can simplify this, right? So this is a positive number, this is a negative number, by the way, positive 5 to a negative, and the answer will be negative. So you just take care of the sign first. And then the 3 goes into 12, right? 3 divides 3 in 1 time, 3 divides 12 in 4 times. Okay? So it's 5 times 1, 4 times 1. So negative 5/4. Okay? So that's how we do this one. So whether the fraction is a positive or negative number, you get rid of it by multiplying by the reciprocal. Okay, so what have we learned so far? We learned to solve simple equations like this, or negative 3x equals 12, and I suggested to you how to solve equations that have fractions in front of the x like that. All these circumstances, the constant term was multiplied to the x like that. Okay, let's move on. How about this? X plus 5 equals 7. Okay, now in this case, the 5 is attached to the x with the addition sign. So we do the opposite operation. So we subtract 5 from both sides. Because if you subtract 5 from both sides, okay, then you get x here. 5 minus 5 is 0. 7 minus 5 is 2. This is just x equals 2. So we do the opposite operation, like that. How about if I had like x minus 5 equals minus 3. Okay, we want to get rid of this 5, so it's subtracted here, so we add 5 to both sides, like this. Alright, so then we have, that's gone, right? Minus 5 is just x over here. X equals negative 3 plus 5 is positive 2. Okay, that's that. Now let's do some more complicated questions. Let's start with the one that we started with, like this. Now here, see, we have to take this step by step. Now we start, what do you do first? You divide both sides by 3 like this, like that, or you get rid of the 5 first? Well, you get rid of the 5 first because that's like opening the ribbon. You start farther from the x, okay, farthest from the x. So your first objective is to eliminate the 5. You can't just subtract 5 from this side. Right? That would be wrong, right? Because whatever you do to one side, you have to do to the other side, okay, like that. So subtract 5 from both sides, that's 0. So let's get 3x plus 0. You can ignore the 0, right? It's just 0. 7 minus 5 is 2. And then I divide both sides by 3 because that's how I want to get rid of the 3, like this. So that's gone. So then this becomes 1x, or just x equals 2/3. Okay, and that's the answer. If you wanted to check, if you wanted to see if you're correct, so you could do a check. See, this is how you do a check. You substitute the value of x that you discovered into the equation. So you substitute 2/3 in place of x. Okay, like this. Okay, plus 5. Does that equal to 7? Did we do this correctly? Did I make a silly math mistake? Okay, well, let's see. 3 times 2/3. Okay, 3 goes in there one time. Okay, that's 2 times 1 is 2 plus 5 equals 7. Does 2 plus 5 equal 7? Yes, 7 equals 7. So we did it correctly. Okay? Alright, now let's do more. Right, minus 2x plus 4 equals 18. Okay, let's do this. Simple enough. You subtract 4 from both sides. You say, okay, let's do that. And then that's minus 2x. 4 minus 4 is 0. Equals 18 minus 4 is 14. And then we have to get rid of this negative 2, right? So you divide both sides by negative 2. Negative 2. Because negative 2 divided by negative 2 is just 1. So this becomes 1x equals 14 divided by negative 2 is negative 7. Negative divided, or positive divided by negative is a negative number. X is equal to negative 7. Alright, I'll show you one more. How about this one? 5 minus x equals 13. Okay, well, the variable is over here and the numbers over there. Well, no worries. Same principles. So we have to get rid of the 5, right? Okay, let's get rid of the 5. Okay, like this. So that's gone. And what's left over here? 5 minus 5 is 0. That's gone. This negative x is left over here. Minus, because there's a 1. So negative x equals 13 minus 5? 7, right? Now we're not done yet though, because this is negative x. We want to know what x is. Who cares about what negative x is, right? So, okay, so you have to get rid of this negative here. How do you do that? Well, you recall that there's an invisible 1 here. It's just like negative 1x. Well, 1 is a respectable number, just like any other number, right? So, how do you get rid of this if this was a negative 2x equals 7? Well, you divide both sides by negative 2. Same thing here. You divide both sides by negative 1 because there's a negative 1 there. So negative 1 like this. So negative 1 divided by negative 1 is just 1. X is equal to 7 divided by negative 1 is negative 7 like this. Got it? Okay. Let's keep going. I'll give you another one. These are going to get more and more complicated. Watch this one. 2 times x plus 3. Okay. Minus 4 equals 20. Now we have some work to do. So we have this in parentheses. So the first thing that we do, we deal with the parentheses, because why? That's the order of operations. Parentheses first, right? So here we distribute the 2 over here using the distributive property, which if you recall is this. A times the quantity b plus c equals ab plus ac. That's the distributive property. So we distribute the 2. This becomes 2 times x plus 2 times 3 minus 4 equals 20. Well, this is 2x plus 6 minus 4 equals 20. Let's simplify. Now you see, what do we do now? What we do now is we combine like terms. So when I ask you, what do we do now? You don't say, you take 6 minus 4 and you get 2. Don't say that. That's correct, but say this. Those are like, hoo, that will give you bonus points, okay? So combine like terms. These are like terms. You combine them, okay? So it's just cool to say, you know what you're doing, right? So 2x, 6 minus 4 is 2, equals 20. So you combine the like terms. Well, now what? Well, we have to get rid of these. Okay, we'll subtract 2 from both sides, outside in, the onion method. Okay, so that's 2x, that's gone, is 18. And then, well, you divide both sides by 2, then x is equal to 9. Ta-da. Okay, that's easy enough to say. Okay, let's do this. Minus 3 times x minus 1 plus 4x equals 21. Okay? Alright. Well, same thing. We distribute. What's the distributive property? If they ask you what's the distributive property, somebody stops you on the street and say, what's the distributive property? you say, well, distributive property says for all real numbers, if A times all real numbers A, B, and C, A times the quantity B plus C equals AB plus AC. That's what you have to say. Okay. Now, same thing. Let's distribute. So negative 3 times x is negative 3x. And then you distributed negative 3 to negative 1. It's negative 3. And then 4x is, you said, what? I hope you did that because I did it incorrectly, right? What did I do wrong? What did I do wrong? Okay, what I did wrong is this. Negative 3 times negative 1 is not negative. It's a common mistake from kids. They like forget it's like whenever negative sign comes, there's something happens, like a short circuit in their brain or something like that. No, be careful with negative signs. Negative 3 times negative 1, okay? You just, if you want to write this, okay, it says negative 3 times negative 1. So what sign do you put over here, right? Well, it's the sign that belongs to this guy right here. So it's negative 3 times negative 1 plus 4x equals 21. Okay, so you have negative 3x. So negative 3 times negative 1 is positive 3 plus 4x equals 21. Now what do? Well, you subtract 3 from both sides to get rid of this 3. Okay, no. Here, it's not wrong, but what we do here is we combine the like terms. These are like terms. What are like terms? They're terms that have the same variable to the same exponent. So negative 3x plus 4x, that's what we have here. That's just 1x. Okay? So this combines to 1x, and then they have the 3 equals 21. And then we subtract 3 from both sides, like this. Okay? Then we get x is equal to 18. Okay? X is equal to 18. And so next time what we're going to do is we're going to actually take more complicated examples of equations that to solve. Until then, I hope you've mastered this. And until then, I'll see you. As-salatu was-salamu ala rasulillah. Alhamdulillah rabbil alamin. Assalamu alaikum.